Assalamu alaikum from FY Math Lounge. Hope you're all doing well. And the topic that we are going to start today is quadratics. It's the first topic on quadratics, so it's going to be the introductory class, and then we will carry on with the basic factorization. So quadratics is the topic which students do in O level, and then this topic also continues in the A level and makes a very strong foundation for the A level math course. So to start with quadratics, we know that quadratic equations are the polynomials with the highest power, which is equal to a 1. It's ax squared plus bx plus c. This can be equal to 0. So this makes the quadratic equations. The highest power is a square. Now for this quadratic equation, the constant a and the y-intercept c, the coefficient of x square, which is a, and the constant, which is the y-intercept, that's c in the equation, has a great significance. So first, to start quadratics, we need to understand the significance of a as well as the significance of the y-intercept. So the significance of a is that if this coefficient of x square a is a positive, meaning if I say that my a is greater than 0, meaning this a has a positive value, then always we will be having the curve with a minimum turning point. And if this a is less than 0, meaning if it is a negative, then we will be having the curve with a maximum turning point. These 2 points, they are the turning points here. In this case, we have the minimum turning point, and in the second case, we have the maximum turning point. So just by looking at the coefficient of x square a, the sign of the coefficient of x square a, we can tell the shape of the quadratic curve. If this a is a positive, we can say that the curve is going to have a minimum turning point, and if this a is a negative, then we say that the curve is going to have a maximum turning point. The c in the equation, let's move to c. The c in the equation is the y-intercept, meaning it's the point where the curve intersects the y-axis, and wherever it intersects the y-axis, we know that our x needs to be a 0, and then this point will be having a particular y value here. So let's start with an example. Solve x squared plus 8x plus 12 is equal to 0. So looking at this equation, I know that the coefficient of x squared is a positive. Therefore, I know the shape of the curve. The shape of the curve needs to have a minimum turning point. So this is very much clear from the equation that we have at the moment. Then to solve the equation, then to solve the equation, I need to factorize this curve. And to factorize this curve, what we do is to factorize this equation, we have to take the factors of 12 so that it can break into the middle term. The sum or the difference of the two factors should be giving the answer as the middle term, and I can say that this is an x squared plus 2x plus 6x plus 12, which is equal to 0. 2 and 6, they are the factors of 12. I can see that 12 is equals to 2 times 6, which gives me a 12. And also I can see that if I add a 2 and a 6, I'm getting the middle term, which is an 8. So these are the two verifications that we have to make while solving a quadratic equation, while factorizing a quadratic equation. So then I need to take common, and it should be x plus 2 and then plus 6 common, and then again it's an x plus 2, which is equals to 0. And I can say that x plus 2 and x plus 6 is equal to 0. From here, I can say that the two x values are going to be x is equals to -2 and x is equals to -6. Now here I would like to elaborate on the concept of equating an equation to 0. Whenever you equate an equation to 0, just remember, then equating it to 0 means that basically you are finding the x-intercepts, because at these points, at this value, our y is equals to 0. When we say that we have equated an equation to 0, that means we are equating the quadratic expression and comparing it with the x-axis equation being y is equal to 0. If this is the x-axis, I know that my equation of the x-axis is y is equal to 0. That means the two x values that we have here are basically the x-intercepts, and the x-intercepts here are going to be -2 and -6, and these are the x-intercepts or the roots of the quadratic curve, and I know that the coefficient of x square was a positive, therefore the curve should be having a minimum turning point here. So now I can sketch the curve with respect to the x-intercepts, which are -2 and -6, and also I know from the coefficient of x square, which is a positive, that this curve is going to have a minimum turning point. So this is how very easily I can sketch the curve. The y-intercept in the equation can also be sketched. The y-intercept is a 12. It's the constant in the equation. So I can just extend the curve a little, and I can say that this is the y-axis here, so that on the y-axis, the curve is going to intercept at 12 here. So this is the quadratic curve. Another significance of this is I can also have the mid value of -6 and -2. I can get the midpoint. I know that the midpoint is x1 plus x2 divided by 2. So that can be -6, -2 divided by 2, which gives me -8 divided by 2, and my answer is a -4. Meaning -4, x is a -4, is actually the line of symmetry of this curve. X equals -4 is the line of symmetry of the curve passing through the turning point. So the line of symmetry for a quadratic curve always passes through the turning point where my x coordinate is a -4. So now the question arises, if your x is a -4, what can be the y coordinate? So to get the y coordinate, I can simply substitute this x equals -4 in the quadratic equation, which is x squared plus 8x plus 12. Now I know x is a -4, so the corresponding y value here is going to be -4 the whole square plus 8 times -4 and then a plus 12, or I can say that my answer is a 16 minus 32 plus 12, which will give me a, so this gives me the y value as a -8, meaning I have the y coordinate of the turning point as well, and this y coordinate of the turning point is a -8 here. So this is how I can easily sketch a quadratic curve. I can get the x-intercepts of the equation by factorizing the quadratic equation. I will be knowing the y-intercept from the given equation, and very important is that I know the shape of the curve just with respect to the coefficient of x squared being a negative or a positive. The midpoint gives us the line of symmetry of the curve, and that midpoint x coordinate substituted back in the equation will give us the y coordinate of the turning point. So this is the basic of a quadratic equation. Let's do another example to see how this can be solved further. Let's solve another equation. Solve and sketch the quadratic curve 2x squared plus 7x minus 9 is equal to 0. So again, just by looking at this equation, I know that my a value is a 2, which is greater than 0. Therefore, the curve should be having a minimum turning point. I know the shape of the curve very well. I know this is how the shape of the curve needs to be. Then I know that my y-intercept is going to be a negative 9 also. So these are the two informations that I have from this equation. Now, if I need to sketch it properly, I should be having the x-intercepts. The x-intercepts because now the given equation is equated to a 0. So solving it by the method of factorization, it's 2x squared plus 7x minus 9 equals 0. I should get the product of a times c, which in this case is 2 times negative 9, giving me a negative 18. So the factors of 18 that can give me a 7 should be 9 minus 2 can also give me a 7. So this is the middle term that I have, and 18 is the product that I'm getting back with the product of a times c. So solving it, I can say it's a 2x squared plus 9x minus 2x minus 9 is equal to 0. Or rearranging it, I can say it's a 2x squared minus 2x plus 9x minus 9 is equal to 0. 2x common, I'll be left with x minus 1. From here, plus 9 common, I'm left with x minus 1 equals 0. So x minus 1 and 2x plus 9 is equal to 0. And from here, I can say that my x-intercepts are x equals 1 and a negative 9 by 2. So these are the two x-intercepts that I have at the moment. So after getting the x-intercepts, I know that the x-intercepts are 1 and a negative 9 by 2, and also from the equation my y-intercept here was a negative 9. So I have plotted the y-intercept, which is a negative 9. On the y-axis, I have 1 as the x-intercept as well as negative 9 by 2 or a negative 4.5 as the two roots of the given equation, quadratic equation that we have. Now, the last thing that is left is to get the turning point coordinates. So to get the turning point coordinates, I should be getting the midpoint of these x values. So we have very well sketched the curve, and we know that the x-intercepts are negative 9 by 2 or negative 4.5 or a positive 1. We know the y-intercept from the equation. It was a negative 9. We know the shape of the curve being a positive coefficient of x squared. It's a minimum. Now, the only thing that is left is to get the minimum turning point coordinates. So to do that, I need to have the midpoint coordinate of the two x-intercepts. So I have 1 minus 4.5 divided by 2, giving me a negative 1.75, giving me a negative 1.75, meaning the turning point here should be passing through the line of symmetry, which is x is equals to negative 1.75, and the turning point will also be having the x coordinate as negative 1.75. The only thing now left is to get the y coordinate when your x is a negative 1.75. Substitute that in the equation. So y equals 2x squared plus 7x minus 9 was our equation here. So in that equation, I substituted x as negative 1.75 and got the y value, which was negative 121 divided by 8 or negative 15.125. So my y coordinate here of the turning point is a negative 15.125 here. So I have the turning point x and y coordinates as well. I have the turning point x coordinates as x and y coordinates, and I have completed the solving of the equation with the method of factorization, and I have also sketched the curve very easily. So let's do a word problem. So the word problem says we have a piece of card of length 2x minus 1 centimeters and a width of x plus 2 centimeters. A square of side x centimeters is removed from the card. The area of the card that is left is 68 centimeters square. So find the area of the card that has been removed. So to understand the question, let's make this diagram first. The length of the card was 2x minus 1 and the width is an x plus 2. So I have made this rectangle of length 2x minus 1 and the width x plus 2. The shaded area represents x by x because this part is getting removed from the original piece of card that we have here, and the area that is left according to the question is a 68 centimeter square. It's the left area. So the unshaded area in the diagram is the area which is left, which is 68 centimeters square. Now, understanding the question, it tells us that the area of the card minus the area of the shaded region, the square which I have removed, will be giving me the area which is left, and that is going to be 68 centimeters square. I know that for area of rectangle, it has to be 2x minus 1 times x plus 2, and the area of the shaded region needs to be an x square, and this is equals to a 68. So solving this, I can say that it is 2x times x plus 2 minus 1 times x plus 2 minus x square, which is equals to 68, or I can say this is 2x square plus 4x minus x minus 2 minus x square minus 68, which is equal to 0. Or I can say it's an x square plus 3x minus 70, which is equals to 0 here. Now, just doing the factorization, I know that for 70, it should be x square plus 10x minus 7x, giving me a 3x and a minus 70, which is equals to 0. X common, I'll be left with x plus 10 minus 7. I'll be again left with x plus 10, which is equals to 0. Or I can say it is x plus 10 and x minus 7, which is equals to 0. The two x values that I can have are minus 10 and x is equals to 7. Now here, because we know that we are talking about the length of the card that has been removed, and length can never be a negative, therefore x equals negative 10 is going to be the value, which is not possible. But we can say that the area or the length of the card that has been removed is equal to x centimeters. So according to the question, we were supposed to find the area of the card that has been removed. We need to find the area of the card that has been removed. This is what we are supposed to find out. The area of the card that has been removed here. So the area which is removed was x by x. So I can simply say that the area which is removed is going to be, I can very easily say that the area removed should be equal to 7 by 7, and that is equals to a 49 centimeter square. Let's do another example. It says solve and sketch for 8 minus 2x minus x square equals to 0. So solving the equation, I can say that I can arrange the equation with the highest power so that it is negative x square negative 2x plus 8 is equal to a 0. Now, I can see here that the coefficient of x square being negative, I should be having a maximum turning point curve. But being an equation, what we can do is, for the purpose of simplicity or to solve a quadratic equation easily, we can just take out the negative sign common so that I can say it's an x square plus 2x minus 8, which is equals to 0. This negative here, this negative which we have taken common, can be eliminated by just dividing it by a 0 or taking it to the right side, which is already equated to a 0, so that we can say that we are left here with x square plus 2x minus 8, which is equal to 0. Now we have just brought the equation to the positive coefficient of x square form so that it can be solved very easily. And now we can say that this equation is having a minimum turning point because the coefficient of x squared now is a positive here. So the factors of 8 which can give us the middle term as 2 are obviously 4 and 2. And I can just solve the equation by saying it's an x squared plus 4x minus 2x minus 8, which is equals to 0. Grouping them, this is x plus 4 and negative 2 common, and I'm left with x plus 4 again, which gives me a 0. So that I can say that it's x minus 2, x plus 4, which is equal to 0. Or from here, I can say x is equals to 2 and a negative 4. So these are the two x-intercepts that I have from the equation. Already we have converted the negative coefficient x squared equation to the positive form. So we know that the curve now is going to have a minimum turning point with the roots of the equation as negative 4 and 2. Next thing is to get, and also we know that the y-intercept of the equation here is positive 8. The next thing is to get the turning point coordinates. For that, apply the midpoint formula, which should be x1 plus x2 divided by 2. Or we can say this is 2 negative 4 divided by 2. And that can give me the answer, which is negative 2 divided by 2. So now I know that the turning point x coordinate is going to be a negative 1. I can substitute this negative 1 back in the equation, which is x squared plus 2x minus 8, which is equals to 0. So to find the y coordinate of the turning point, I know that the x coordinate of the turning point is a negative 1. Substitute negative 1 in the equation. It's negative 1 the whole square plus 2 times negative 1, negative 8 equals 0, or 1 negative 2 negative 8 equals 0. So substituting x turning point coordinate as a negative 1 in the equation, which is x squared plus 2x minus 8 equals 0, or I can say that this equation was y, because we are finding out the turning point coordinate of y. It's y, which is equals to x squared plus 2x minus 8 equals 0. So to get the y turning point coordinates, just substitute x as negative 1 and I'm getting the coordinates as a negative 9. So the turning point coordinates that we have here are negative 1 and negative 9. The y-intercept of the equation, let's call it c, is a negative 8. I know that it's a minimum natured curve. It has a minimum turning point, and I know the roots of the equation. The roots are the x coordinates that we just found. They were negative 4 and 2. So with this information, very easily I can sketch the curve and I can say that this is my x-axis here. So with the help of the information, I have sketched the curve very easily. My x-intercepts or the roots were negative 4 and 2. So I have negative 4 and 2 here. The midpoint coordinates for the turning point we found were negative 1 and a negative 9. So negative 1, so this is the line of symmetry of the curve that we have, and negative 9 is obviously the y coordinate of the turning point. The equation has the intercept, the constant, which was a negative 8. So the y-intercept was a negative 8. We have shown the y-intercept also on the diagram, and this is how we have solved the quadratic equation. So I hope the concept of quadratic equation and factorization for sketching the curve is very much clear to every one of you. So if you like the video, please give me a thumbs up. Don't forget to subscribe and watch the next one for solving quadratics with inequalities and further topics of quadratic equations. Thank you for watching. Allah Hafiz.